And welcome to 90 Notes, the iSchool version. Hey, geometers, by now you're getting used to our new curriculum for the COVID-19 pandemic. And we're using iSchool, we're following iSchool, but I'm going to keep referencing our textbook in the lower right-hand corner. And right here, we're going to be working with circles. We've got 10 questions on this exam. And, well, I just want to give you a little bit of notes on how you might want to answer these. And again, you can't have two windows open during the test, so you can study this video and take notes, and it should help you in the test. So let's get to it. This is the first question. Gosh, this is a strange one. I'm describing this circle in blue, and with a radius of 5, and the circle in green with a different center and a radius of 10. What steps will show that circle A is similar to circle B? And I suppose I should mention that circles are named by their centers, in this case A and B for the blue and the green circle. And I find this an odd question since, well, by definition, all circles are similar. I mean, every circle has a ratio of circumference to diameter of pi. That's the very definition of pi. So again, I think this is an odd one, but let's see if I were to answer this. The only one, there's 4 of these here, and I made, just for a little fun, I made a little animation of all 4. Really, only A makes sense, because if you were to take choice A, that is, if you were going to take that blue circle and you were going to dilate it by a factor of 2, you of course are going to give it a radius of 10. You know, I guess that's the closest thing to showing that the two circles are similar. By comparison, let's take choice B. Let's translate it by this rule. You remember this. We did this in the beginning of school. Now, if I were to translate it, that means I'm moving it in this direction. It doesn't show similarity at all. Well, I guess it doesn't show congruence. It doesn't show, I don't think it shows anything, honestly. How about if I were to take it and rotate 180 degrees around the center? Well, okay, well, that's okay. And D, if I'm reflecting it across the y-axis. So there you go, I'm reflecting it across the y-axis. Those are the 4, and honestly, you know, maybe this one is the only one that kind of makes sense to me. I'd go with choice A, even though I think this is a very odd question. Okay, well, enough of that, geometers. Let's look at another one. Heavens to Murgatroyd, so they just want you. You know, they're not going to ask this. They're going to ask you in a multiple choice kind of way. They'll say, well, name the tangent, or name the secant, name the chord. So let's just go through this. If I were looking at this thing, first off, this guy up here, MN, touches the circle in one point. That is the very definition of a tangent. So the line MN is the tangent. Now, of course, the radius is a segment. And the secant's pretty interesting, because a secant is a line that touches a circle in 2 places, and the only one that could possibly be is ST. And of course, the chord is contained inside that secant, and the chord would be QR, because the chord has its endpoints on the circle. Now, if the person writing this were really nasty to you, you could actually be tricked by something like this. You keep in mind, these 2 are the same line, ST and QR. I hope they don't do something like that to you, because this and this are not the same thing. This is a secant. This is a chord. Remember, the endpoints of the chord are on the circle. So that should get you through question number 2. All right, let's go on to 3. The pizza, another definition back in section 10.1. Well, this is, I don't know, pretty straightforward. What does the curve, and they took this straight from there, the curve AB, not the area. This thing is a sector. An area is a sector. The pizza you eat is a sector. And if you just leave the crust behind, the crust is going to be the arc. Now, remember, it's not a chord. That doesn't make sense. Not a circumference is all the way around, and it's certainly not a tangent. Tangent would be a line that's exterior to the circle. So this curved spot, the only thing that makes sense to me is an arc. Gosh, that was, all right, so the first three were pretty easy. Let's see if they get a little more exciting. Well, okay, Theorem 10.7, back in section 10.4 of our textbook, we've learned that the inscribed angle is exactly 1/2 the intercepted arc. Now, this is a typical question where you've got more than one way to answer it. Now, I put the little blue tick mark here. This is what you're after. This blue angle, the angle PQR, intercepts the blue arc. Well, that means the angle here intercepts the red arc. So you've got two ways to go here. Now, you can get the same answer either way. I mean, you could say 46. Well, half of 46 is 23. So this angle must be 23. And then you've got a right triangle there. The corollary to the triangle sum theorem says these two angles have to be, yeah, you guess it, these two angles have to be complementary. So that's one way, one of the two ways you could do it. Alternatively, you could have said this. You know, you could have said, well, 146 and 134 makes the semicircle, which is they must add up to 180. And then you could take the 134 and you can divide by 2. Those dang pop-ups. 134 divide by 2 and you'll still get the same thing, 67. So either way, that's a fun problem. And remember, it's only working because PQ is a diameter. So that's why you know this. And that works out pretty well for you. So, gosh, and I think they're going to give that to you in a multiple choice format. So easy, squeezy. Hey, we're almost halfway through this. Let's get to it. Now, finally, one that's a little bit of a two-step. This is an interesting problem because it takes in section 10.5, we learned something about this is a secant tangent angle. Now, I want to point something out here that your book doesn't say enough, or say, I want to remind you that a secant, they just told you in section 1 that a secant is a line and a tangent is a line. So I want, you will see in this language, a tangent segment, a secant segment. So we're just trimming those lines up a little bit. And that's what so in this example, we've got a tangent and we've got a secant that meet outside the circle at Charlie. And we've got two intercepted arcs, the far one and the near one. And as we said in an earlier film, red minus blue, divide by 2. Just love that. And that's all you need, except, hey, you need to know what is blue. And you're going to go back to your earlier section, which is to say, this is an angle, or this angle, the angle at B, is an inscribed angle. It intercepts an 82-degree arc. Now you can fill in the blanks. And all you got to do is take 144 minus 82, and then you're going to divide that by 2, and there you go. So again, I'm giving you different numbers. You take notes on this, and you're going to have to work out with other numbers, and and it'll be fine. And problems might be a little bit different, but they should be close. Okay, number 6. I love this because we do a lot of constructions. We've done these, except that I want to point out this is way back in chapter 5. I know in iSchool apparently they arrange it differently, but we did these constructions long time ago. And I reviewed these in the previous quiz, but I'm going to show you these two because the language is tricky. Which of the following is a step constructing a circle circumscribed about a triangle? Now, when the circle is circumscribed about a triangle, That's the same as saying the triangle is inscribed inside the circle. Or just look, you got to think of it this way, just like the book, The Little Prince. Well, you got the circles on the outside. That's what you're looking for in this particular case. So the language is saying the circle is about. That means it's around a triangle. Now, of these four, only two of them are close. And we'll just go through them pretty quickly. I've got an angle bisector on the left here on ABC, and I've got a perpendicular bisector on HJK. I'm going to step through them a little bit and see, and I'll just let you make up your mind. Remember, those are your compass wings, and then you've got that, and that is an angle bisector. Compass wings gives you that point. There's your angle bisector. And then you've got the in-center. And if you do this, now you probably remember that. By contrast, I'm going to do the perpendicular bisector swings here for HK. I've got this line. I'm going to do the perpendicular bisector swings for JK. I've got that line. That is the circumcenter. And then if I were to do this, so you got circles on the inside, you got circles on the outside. I think you can make up your mind which one it is. Okay, two great constructions. Let's move on to number 7. Heavens to Murgatroyd. Oh my goodness. Now, I actually snapped a picture from your screen. I like to make my own diagrams, but I got to show you this. I don't think any of these are right. Well, okay, technically one of them is correct, but it's not very useful. The concept is pretty straightforward. We're saying we know that a inscribed quadrilateral, the opposite angles are supplementary. Now, that makes the first choice, I guess, correct, but it's not going to help you solve it. So this is actually a ridiculous question. If I had to answer this, I'd probably go with that one because it makes sense. The other ones are just plain wrong. But let's look at how you would actually really solve it. So in a hypothetical problem that I made up before, we did this before, but now I'm going to solve for angle P. And let's see, how would you find that? Now, if you've got one variable, the only way you could solve for this, you're going to set up the two opposite angles. That's these two. You got to use these two because they're the only ones where you have expressions for them. I would set them equal to 180. Remember, we already did this. We cranked through the arithmetic and we got 12. Now, I could substitute that in there and that gives me these two angles. But I really don't care because that's not what I'm after. I'm after the angle at P. So I could do this, taking that value of x that I solved. I could substitute it into here, find 71, and then I could take that and say that's 109. So, well, that's really how I would solve that. But that's an extra step. They didn't really give you that, or it wasn't that clear from the choices. So make your best choice. If you have a question about it, contact me in office hours. Okay. Why? 8, 9, 10. Let's get going. Almost done. Oh, we're going to do some drawing. Section 10.7 of our textbook. And this is really easy stuff. It's really cool. It's just like you guys did with the parabola. The H and K stand for the center of the circle. Okay. Now I made up 2 different examples for you, just so we could write them down. And I'm going to put a center at -5, +3. We're just going to draw that there. This is -5, +3. And I'm going to make that a radius of 4. 1, 2, 3, 4. And let's make that, make the color blue to match the text and make that stand out a little bit. Now, if I want the equation of that circle, well, all I've got to do is substitute into the h and the k. And then I'm going to say, well, right there, I'm going to say x minus -5, of course, can be simplified. And I remember I square the 4 and I have 16. That's all there is to it. That is the equation of the circle. Now, let's do a different one. Let's do the red one, and we're going to say that that's, and again, I picked something that's, got a positive and a negative because it's more interesting. There's 4, -2, and it's got a radius of 3. And I'm going to go 1, 2, 3 this way. And I'll make that circle red. So now, same thing. I substitute, and I get my equation. Remember, minus the -2 is +2, 3 squared is 9. But now I'm going to do something different. I want to just show you something. I'm going to do a test, a verify, just like you did with linear equations. Let's take this point right here. What are the coordinates of this point? It looks like it's 4, 1. Now, it's easy to get what I call the cardinal headings because obviously you can move up 3 units to the right, 3 units down. All these other ones, all these other points around the circle, most of them are going to be non-integral values. But I know that it goes through 4, 1. So watch this. I'm going to substitute. X is 4 and y is 1. And test that out. 4 minus 4 is 0. 1 plus 2 is 3. 3 squared is 9. That looks like it checks out A-OK. Just like it would, just like you do in a linear equation. If you pick any point that is on the circle, it should satisfy this equation. And that's a little, probably a little more than the question asked, but you need to know this stuff because after all, you're going to Algebra 2. All right, a couple more. Oh, the cattle. Oh my God, this, they went on and on about this cattle thing, and our textbook covers this in section 11.4, oddly enough in the area section, but this is interesting. This is actually called, this is arc length. And I want to point this out. This guy talked all about this, and he said start, like he's going to go over here, and then he's going to come back. But I read this several times, and it was very clear. They were talking about the distance traveled from here to here, not round trip. So, and I worked it out, and that means you're going to do this. How far is that distance? And that is an arc. And we're going to say that that is an arc length. Arc length, we always use this funny lowercase l for arc length. Again, 11.4 in our textbook. And it's a fractional part of the circumference of the circle. Because remember, the circumference is all the way around, and a fractional part, well, is n degrees out of 360 degrees. I mean, this one's easy. It's going to be a quarter because it's 93/60. Or it's a quarter of a circle. But that would be in general case. So let's take that and substitute. And in this hypothetical example, I gave you 100 feet. Your question will be 70 or 80 or 75 or something else. But let's suppose I've got that. And that's going to be the arc length. Super, super easy. And if I were to simplify that, that's a quarter of a circle. Notice the degree signs divide out because it is a ratio. It'll become unitless. And I've got half, I've got a quarter of 2. Well, that's a half. Half of 100 is 50. So in the end, it looks like I've got 50 pi feet. And honestly, I don't know if this one's a multiple choice or if you have to plug it in, get a decimal. If you are getting a decimal, if they don't tell you to use 3.14, then I want you to use the pi key. So again, pay attention to the detail. Well, I think I've got it right here. Based on what distance will the handle remove from the starting. I think this one's going to be a multiple choice, and they're going to give you the setup. They want something probably like that. So just pay attention and make sure you're taking a fractional part of a circumference. All there is to it for arc length. And from arc length, we'll move on to our last topic, which is the area of the sector. And this one said or write an expression. So this one will definitely be a multiple choice. And what's the difference? Well, area is this. When I sweep through that region, it's the area of this shaded region. Now, just like before, it is a fractional part of a circle. The area of a circle is pi r squared, and in this case, n is the number of degrees, and then you would make a substitution and it might be something like that. And that's as far as I'm going to take it, because the rest is just arithmetic. And I know you can do that. So you remember, in this case, you've got to square the 12, and you've got 43 divided by 360. This one won't be so pretty. And I think you're just going to set the problem up here. Of course, the unit will be square millimeters, because when I take this 12, that's 12 millimeters. I square it. I've got square millimeters. So set up that problem, and you've got 10 problems done. Congratulations on getting through part 1 of your test. And I want to thank you for watching Nani Notes.